We want to make corporate contracts more secure by use of blockchain and machine learning technology. We want contracts to be tamper-proof, we want contracts to be forge-proof, and lastly, we want contracts to be friendly. Our solution is this. Instead of signing a contract only on paper, why not import it to the digital world? Then, as an additional security measure, use an encrypted piece of your information, such as tax return information. This information is only accessible to you and your government. Then the signee uses the same information. The information is encrypted and then put into the contract. Then the contract is encrypted again and sent to the blockchain. By sending it to the blockchain, this means that the encrypted version of the contract is stored everywhere and that the contract can't be manipulated once it's signed. In addition, each person that signs the contract gets a special key. This key allows them to download the contract from the blockchain, unencrypt it, and read it. To start the front end of the application, you can simply run the following bash script, run end user app.bash. Once you run it, you're going to see something like this. This is the main menu of the front end, and here you can create a contract, verify a contract to verify the people that actually signed it, and you can also download a contract from the blockchain. So first, let's create a contract. This is assuming you already have the contract written up in some sort of a file. As you can see, the contract that I have submitted has been flagged as very ambiguous. I might want it to be rewritten. So I'm going to sign it. I'm going to sign it with, say, my SIN. The next person is going to sign it, and they're going to sign it with their SIN as well. And the signatures have been completed. And now we have files. Right? Me and James both have our own separate files that we can use as our own keys. And this contract has now been sent to the blockchain. So what we can do is verify our contracts. So for example, say that James claims he never signed my contract and now we're in court over it. Well, all I have to do is upload my contract, which I received. And now I have to enter the information that I used with this contract. Now, all the court has to do is input James's SIN, and as you can see, the program claims that we have both signed our contracts. And suppose that I were to use some sort of incorrect information. Well, our SINs didn't match up with the encrypted signatures of the contracts, and so apparently we have not signed these contracts. One last thing you can do is read a contract from this blockchain. And the contract has been saved in the saved contracts folder. BlockContracts is powered by a custom-made blockchain network. That's right, we made the network ourselves in Python, and it is backed by SHA-256 encryption. To ensure that at least one node on our blockchain is always running, we are hosting one of the nodes on the DigitalOcean Linux server. We're also using a custom TensorFlow 2 model to detect ambiguity in contracts. Our model uses text embeddings along with a neural network in order to detect ambiguity in phrases throughout the entire contract. Our dataset is public domain, and we managed to achieve an accuracy of approximately 87%. To ensure our contracts are encrypted, we are using the Fernet Symmetric Encryption API.